This is the class of transformation of continuous random variable and very important topic of probability. Here we discuss how to transform the PDF from one random variable to another random variable. And the transformation law is this: if capital X be continuous random variable having PDF f of x, and let capital Y, this is equal to phi of capital X. This is the transformation of random variable. We know the PDF of x and we have to find the PDF of y, where y is a function of x. With the change of random variable from x to y, where phi of x, this function, this transformation function must be differentiable and keeps constant sign. That is, either phi dash x greater than 0 or phi dash x less than 0 for all x. This is means keeps the constant sign, either positive or negative. Then the PDF of y is given by g of y. This is equal to f of x into mod of dx by dy. Now we prove this result. We prove this result in two cases. Case 1. Here we let phi dash x greater than 0, and in real variable phi dash x is greater than 0, because in real variable capital X is small x. This is the random variable and real value of capital X is small x, and this means dy dx greater than 0, because y equal to phi of x and the derivative of y with respect to x greater than 0, and this gives phi of x is monotonic increasing, or we say strictly monotonic increasing. Strictly monotonic increasing for all x. Let capital F of x be the CDF. This means distribution function. Or cumulative distribution function of capital X. And g of y is the CDF of capital Y. This is the CDF of capital X, and g of y is the CDF of capital Y. CDF of capital Y. We know that from the definition of CDF and PDF, capital F dash x, this is equal to small f of x, and capital G dash y, this is equal to g of y, where f of x is the PDF of capital X and g of y is the PDF of capital Y. Now capital X less equal to small x, this is implies and implied by phi of capital X less equal to phi of small x, because phi is monotonic or strictly monotonic increasing function, and the definition of monotonic increasing function is x1 less equal to x2 implies and implied by phi of x1, this is equal to phi of x2 less equal to phi of x2. So capital X less equal to small x must be implies and implied by phi of x less equal to phi of x. And in the concept of probability, we say that capital X less equal to small x implies and implied by capital Y less equal to small y, because we say and in real variable this, because of this event imply this event, and this event is also implied this event, so we can write P of capital X less equal to small x, this is equal to P of capital Y less equal to small y. From the definition of CDF, we can write capital F of x, this is equal to capital G of y. Differentiating both sides with respect to x, we get f dash x, this is equal to g dash y into dy by dx, and this is f of x, this is g of y, this is dy dx, and we can write g of y is equal to f of x into dx dy, and we numbered this as 1. Now we go to the case 2. Obviously, in this case, phi dash x less than 0. So, dy dx less than 0 imply phi of x is strictly monotonic decreasing. And here we get capital X less equal to small x implies and implied by capital Y or phi of x less equal to phi of x. This is implies and implied by capital Y less equal to small y. Now, like this, we get P of capital X greater equal to small x. This is equal to P of capital Y less equal to small y. And this can be written as g of y, but this is 1 minus P of capital X less than small x. And since for a particular point of a continuous distribution P of capital X equal to x is equal to 0, so we can add equal to x here, that is 1 minus P of capital X less equal to small x, this is equal to g of y. Now we write one minus f of x is equal to g of y. Now we differentiate with respect to x again, gives 0 minus f dash x is equal to g dash y into dy dx. We write here small f of x, this is the PDF of capital X, and this is g of y into dy dx, that is g of y, this is equal to minus f of x into dx dy, and we mark this as 2. Now clearly from 1 and from 2 we write g of y, this is equal to f of x into mod of dx dy, and this is the formula of transformation of a continuous random variable. If the transforming function phi of x is not differentiable, or if phi dash x is not keeping the constant sign, then we cannot use this result for transformation of PDF from x to y. This is very important point for this formula. Now, using this formula, we take an example, very important example. Let x is normal M sigma period. Then z is, this is equal to x minus m by sigma, is normal 0 1 period. This is standard normal. Standard normal period. It is given that x is normal 0 1, and we know that the PDF of x is f of x equal to 1 by root 2 pi sigma e to the power minus half into x minus m by sigma the whole square minus infinity less x less infinity. This is the PDF of normal m sigma variant. Now here z, this is equal to x minus m by sigma, and here the restriction is sigma greater than 0. Now dz by dx in real variable we can write first z equal to x minus m by sigma. Now we differentiate this dz by dx. This is equal to 1 by sigma, and this is greater than 0 for all x. So we can use this transformation formula to find the PDF of z. Here we get the PDF of z as phi of z. This is equal to f of x into mod of dx by dz. And f of x is 1 by root 2 pi sigma e to the power minus half into x minus m by sigma the whole square into dx dz. Dx dz means sigma phi of z is equal to 1 by root 2 pi, because sigma sigma cancel, and e to the power minus half into x minus m by sigma. This is equal to z, that is z square. And the range of z is, since range of x is minus infinity to infinity, so the range of z is minus infinity to infinity, that is minus infinity less z less infinity. And we know that this is the PDF of standard normal distribution. For this reason, here we write phi of x in place of, phi of z in place of g of z, because in the formula we write g of y, this is equal to f of x into mod of dx dy, but here we write phi of z in place of g of y. Okay, so if capital X is normal m sigma, then capital Z, which is x minus m by sigma, this is the transformation formula. This is normal 0 1 or standard normal variable.